Well, thank you everyone for coming to this session. We're very excited, and it's a really apt time to be talking about infrastructure with all the news lately. So I'll quickly just introduce myself. I'm Shireen Ghaffari. I'm a reporter at Bloomberg News. I'm based out of San Francisco, where I cover AI. And now I will turn to our panelists. I would actually like you maybe just to each tell a little bit about yourselves and the work you do before we go on to questions. So I'll start with you, Chase.
Cool. Thanks everybody for being here bright and early on Thursday morning at Davos. This is great. But I'm Chase Lochmiller. I'm the co-founder and CEO of Crusoe. Crusoe is a vertically integrated AI infrastructure business. Our goal is to really accelerate AI adoption and sort of get rid of some of the key unblockers and try to scale AI sustainably. We do this in kind of two different major layers of the stack. One is sort of at the data center and energy side of things, like very low down in the stack in terms of that being one of the key unlocks to enabling AI to grow and scale is access to data centers and access to compute. We also offer a purpose-built AI cloud platform that enables innovators to kind of build AI applications and develop generative AI applications and run them on Crusoe Cloud. So that piece of the stack is really trying to make AI more accessible to the masses, right? So we've sort of been able to, for the first time in history, really manufacture intelligence, and our goal as a business is to be able to make that widely distributed to everybody, even if you're not a machine learning engineer. So I'm excited to have this discussion today about scaling AI and what it means from an infrastructure and energy standpoint.
Great, thank you. And Costi?
That's great. Thanks for inviting me. I'm very excited to be here. So hi everyone, I'm Costi Perricos. I'm Deloitte's global GenAI business leader. For those of you who don't know Deloitte, we're one of the biggest professional services firms in the world. And my job is really twofold or threefold really. The first is to make sure that we can help our clients capture this amazing opportunity that AI brings in terms of furthering their businesses and their visions. The second is to do the same for Deloitte. We're a professional services firm. We're part of the knowledge economy. We employ people with great brains, and that creates an existential opportunity, but also an existential threat for us. So part of my role is to see how we can transform ourselves. And then the third bit is, you may notice from my accent that I'm not from the US. I'm actually European. I'm Greek by birth, but I've spent a lot of time in the UK. And part of my goal is to really translate a lot of the amazing things that are coming out of the US and understand their relevance and how they perhaps need to be translated in Europe and other countries, and also understand what's happening outside of the US to see how all that fits in the mix.
Great, thank you. Varun?
Hey folks, I'm Varun, CEO and co-founder at Codeium. We build AI tools to accelerate software development. So Codeium as a platform has over like 1 million developers that currently use the product. We're used by some of the world's largest enterprises like JP Morgan Chase and Dell. And we recently launched an IDE called Windsurf that basically uses agents to help you write more and more software. And I guess the super exciting part is we're seeing basically upwards of 80 to 90% of all committed software getting written by AI now, which is hugely different than what we saw in the original days when products like Copilot came out, I would say like 2 years ago. So I think it's really, really exciting to see what's going to happen in the field of technology creation and software development, and super excited to discuss with you guys today.
Okay, great. And Dave, last but not least.
Yeah, hi, Dave Wehner. I'm the Chief Strategy Officer of Meta, so I think I'm here to give the hyperscaler perspective to the extent that that's pretty relevant probably for the big infrastructure build-out that's happening. I've been at Meta since 2012. For 8 years, I was the CFO. And more recently moved into the Chief Strategy Officer role where I cover corporate development, product strategy, and enterprise engineering. So I'm really pleased to be here. Obviously, AI is very important to Meta. Infrastructure is a big part of what enables us to deliver things like Llama and Meta AI, and we're investing heavily to prepare for the future, which is going to be transformative in terms of what AI can bring to our products and to the rest of the world, which we're trying to support through the open source effort with Llama.
Great. Well, thanks all for those intros. Let's start with the big news this week. There's a $500 billion infrastructure build out, and it's funny, the title of this panel, a big infrastructure build out. I feel like, this is one example, I want to hear your thoughts on the project, and then I wonder, do you think we will be seeing more of these, maybe with different companies involved in the future, these sort of joint infrastructure investments from different major companies across the globe? So I'll start with whoever is itching to answer that question, if anyone wants to take it on. Maybe Chase, you want to go first?
Yeah, no, it was a pretty major announcement, and I think just the sheer volume of capital that was announced is just jaw-dropping in terms of what it means for the investment into the infrastructure layer of AI to really scale this technology. I think it's worth kind of like putting some things in perspective in terms of like how big and what does that mean? What do these big numbers actually mean? I think numbers being thrown around were like this would be something in the order of 20 gigawatts of total capacity being brought online. To put it in perspective of like what that number means, the entire Northern Virginia corridor, so like the Ashburn, Virginia corridor, which is largely seen to be sort of the center of the world for data centers, kind of like the data center mecca, the sort of hub of all data center activity. Today, all of that is about 4.5 gigawatts. So you're talking about building out capacity that for one company that is 4 to 5 times larger than that, right? So really significant sort of both infrastructure investment as well as capital investment. From our perspective, we've been sort of at the cutting edge of building these large scale AI data centers, and a lot of it is shifted in terms of what defines a data center and like what the data center architectures look like. The density of these advanced computing architectures has required completely rethinking the data center in terms of size, scale, cooling, and overall management. So we have a project that's in Abilene, Texas, which I guess kind of got put on the map through some announcements at the White House. But that the first phase that we've announced there is a 206 megawatt data center that we're building fairly quickly. But all of it is sort of purpose built and designed for direct to chip liquid cooling for these next generation high density computing architectures. I think one thing worth noting is that it's a smaller overall footprint. Each building is about 500,000 square feet. In total, it's about 1 million square feet. But if that were a more traditional data center, it would probably be about 3 times larger in terms of square footage. Now we pack in a ton of electrical infrastructure to that site to get those high density computing data halls energized and powered. And sort of the inside looks a bit like the waterworks. Like it's a crazy amount of plumbing that goes into sort of these giant large scale data centers. So relating back to this big announcement, I think the bottlenecks of AI are constantly sort of moving around. And at one point, call it 18 months ago, it was definitely chips being this major bottleneck. Like no one could get enough H100s. I think today it's sort of shifted a lot into data center capacity, energy, and access to large scale quantums of energy. And I think what's interesting about that is the build out requires tremendous labor too. So I think we're going to see this massive boom in blue collar labor trades that are required to make this infrastructure happen. So electricians, plumbers, welders, technicians, just construction workers. We're going to see a boom that is I think the closest equivalent is the New Deal, like when we built out the interstate highway system in the United States. So I think it's an exciting step forward, and I think a lot of progress is going to be made from these types of investments.
Can I
Sure.
comment on that? Because I don't know a lot of the details for the deal, but it sounds incredibly exciting, and I think it is going to further kind of the AI capabilities and vision that we are seeing across the globe. But it is very US centric, and I think particularly as we're in Europe, we need to bear that in mind. There was another announcement early this week. The UK government announced its action plan, and there was quite a bit of hardware build out there. And to me, that's really important because when you're in Europe or you're in the Middle East or in the Far East, where often you've got data residency laws that says you cannot be exporting your data and putting it in a data center in the US, you actually find that your ability to operate is really restrictive and that doesn't reflect the conversations that we might be hearing here today. So, early on when we were doing work with clients and government clients, it was really difficult to find actual GPUs that you could train models on in country. They'd say, well, the nearest one we've got is in Ireland, and if you're in the UK, you can't do that. So for me, I hear everything you're saying, and I think it's fantastic. But hopefully that will also signal to other governments outside of the US that we're going to need kind of in-country residence infrastructure and similar projects to the one you're referring to be able to further the cause of AI globally.
Yeah, thanks.
I would maybe just also add, just to put in context the announcement yesterday, if you look at the hyperscalers in 2020, I think in aggregate, they spent something like $100 billion on CapEx. And by 2025, I think you're looking at $300 billion. So, a massive 3x increase in 5 years. And, you can see those kinds of growth rates continuing if you see announcements like we saw yesterday. So, an incredible amount of capital being put into place. I think you're seeing more financing sources for it. SoftBank's coming in as a financing partner, but we see a number of other parties being interested in helping with financing the data centers and the build out that's happening. So you're seeing capital formation to help support this big infrastructure build as well.
And do you think that we should expect, or we might see more of these kinds of announcements from other companies, other players? Because there is now also, I think, a rising sort of political awareness that every country needs to be beefing up, right, its infrastructure, that data centers and energy are suddenly becoming some of the most top of mind political priorities for new administration. So, Dave, what do you think? Do you think that might compel a little more attention on these? I know Meta has been doing data center buildouts for a very long time, but do you think we might see sort of more attention on this and maybe some splashier, even bigger, bolder announcements from other companies generally?
Well, I don't know about splashier, but I mean, I think we've been building our data centers since we broke ground on our first data center in 2010. We had 6 new data centers come online in 2024. So we've been, substantially ramping capacity for a number of years. And I think the hyperscalers are all doing that as well. I think you'll continue to see others invest in the space beyond the hyperscalers. I think you'll see a lot of other countries look to try and build out capacity. So there's a lot of interest across the globe to partner with hyperscalers. I think you'll see opportunities there and probably some interesting developments on that front. But it's, I think, going to be a continued steady build out and a lot of execution that needs to happen to make all of this work. There's the power industry needs to support it in the US. That's a challenge. We're, I think, rising to the challenge, but there's a lot of supply chain bottlenecks. There's things like electricians and labor and very kind of labor-intensive needs that need to be satisfied. So there's a lot of build-out that needs to happen. There's a lot of supply chain that needs to happen to support it. There's a lot of labor that needs to come into play to execute on it. So I think, the announcements, yes, there's obviously going to be exciting announcements. There's a lot of hard execution to actually deliver on this infrastructure build-out over the next 5 years. And so we're focused on doing that and bringing innovation in how we can do that. Across the value chain. So we're investing in things like, new data center designs. We open source our data center designs through our Open Compute project. We have innovations in places like networking where we're open sourcing designs there. We've got an effort on the chip front with our MTIA chip, which is tuned to the workloads that we need to do. So you're going to see more innovations in places like semiconductors from the hyperscalers and from others and small companies that are innovating in that space. So I think there's a real opportunity for innovation, and then there's a real focus on execution to make all of these things work. Because this is a massive, this is New Deal plus. This is a huge, expansive effort that needs to happen, and you've got a lot of entrepreneurial energy and founder vigor being put into this, which is really exciting. And it is probably one of the most, exciting things I've been able to be a part of and witness. But it's going to be a tremendous amount of execution from here until 2030 to deliver on a lot of this.
Makes sense. And then, speaking of founder energy and actual energy, let's talk a little bit, Chase, about the energy demands here that we mentioned. You're saying that the largest AI corridor in Virginia, right, has what, 4 gigawatts? Is that what you said?
I was saying the entire data center footprint.
Right, data center
that
footprint.
Runs
and
pretty much
now
the whole internet today,
and now
right?
we're talking, in the 20s, right? So how do we power this? What are some ways that your company is looking at innovating on this front? And then also, Varun, I'd love to hear a little bit from you about your perspective on all of this. But let's start with you, Chase.
Sure. I think the interesting aspect of AI as a workload is that it's a bit more tolerant of latency compared to serving a traditional web application. So the opportunity you're seeing with this massive build out is that we're sort of rewriting the data center landscape and what the future of computing and really looks like distributed across the globe. Crusoe's sort of always taken this energy first approach to building compute infrastructure, and instead of sort of trying to build data centers in places where there's a large network of other data centers, we try to first focus on the energy side of things and try to build in areas where we can access low cost, clean and abundant energy. So instead of a market like Ashburn, Virginia, we're focused on a market like Abilene, Texas, that has tremendous amounts of wind and solar that's actually been built out and developed and is actually being underutilized today. Some of our partners there, receive negative pricing on the power about 30% of the time, or significant amounts of curtailment where they could be generating power, but there's no net marginal buyer, so they're just sort of shutting down. I think there's a lot of interesting opportunities like this where the data center and compute build out can work very cohesively with the energy industry to power this both effectively, rapidly, and sustainably. We're pretty excited in terms of this being an opportunity to accelerate a lot of new climate-focused technologies that can really accelerate a lot of net new clean generation.
Great, and Varun, maybe you were talking about coding as an application. It's important to remember, right, what all this energy and data center build out is for. So can you tell us about, how you think the kind of load is going to increase as more and more coding starts to shift to being AI rather than human?
Yeah, so I think one thing that I think people are accurately calling out is these racks are getting more and more dense. But one thing that I just do want to call out is if you actually look at the GPUs now, they're substantially more efficient than they were in the past, right? So like every generation, NVIDIA is pushing out a new GPU that is potentially two times faster, and they're also quantizing it so you can run it in lower precision. So you're basically like the number of flops or the amount of compute you can do per watt is going up by like 2 to 3x basically every generation, right? The only thing is though, the size of the models are higher, the amount of compute we are running is higher, right? And as you can imagine, for some of these agentic workloads where the LLM keeps calling itself over and over again, the amount of power consumption is going to go up. But I think if you were to just look at aggregate productivity, it is just substantially higher than what it was in the past, right? So I think, in some ways it's, I feel like it's a premature optimization for us to be like, hey, how do we cut energy right now? It's similar to how in the 1990s, every 2 years CPUs were getting faster. And game designers could have basically optimized their game for what the hardware is today, but every game designer was optimizing it for what the hardware was 2 years from now because they just knew it was going to get 2 times faster, right? So I think it's super exciting, especially with the new GB200s. It's kind of crazy to think about how NVIDIA has basically made it so that everyone is going to get liquid-cooled racks, right? This was almost unheard of in the previous generation, but for some of these new models, including some of the models that Meta released and probably will release, the number of parameters on these models is going up substantially, right? So it's almost like a requirement to have these incredibly dense racks. Like Chase correctly pointed out that latency doesn't matter a ton for things like training. But for inference, it matters a tremendous amount, right? Especially for these large models, you need to pass a lot of data between these nodes like really, really quickly. And with technologies like the GP200, they've effectively made it so that between nodes, the latency is effectively the same within the node, which is like crazy technological improvement, right? So it's just kind of wild to think about.
I should correct this statement. I think the latency to get to the data center
You're right,
is
yeah.
less relevant. Latency within the data center, super important,
Yes.
especially for the RDMA fabric and the.
And to obviously plus one what Chase basically said, we use Crusoe, and one of the reasons why we can use Crusoe and we don't need to, I guess, use a conventional hyperscaler is because most of the compute and spend actually lives entirely on the GPUs, right? And the amount of data or bandwidth that is required to feed these GPUs is really small. If you look at the data that's required to feed these GPUs, it's just text. It's not really like these really, really dense images. And the amount of compute that goes in the background to actually feed the GPUs is massive, right? Which I guess creates a lot of these new players like Crusoe to become like really, really massive, which is cool to see.
So I think there's a really interesting paradox here, which is the reason how NVIDIA can produce more and more efficient chips, and I'm sure everybody here is using AI in actually creating more efficient data centers, infrastructures, chips designs. And so in order to be more efficient with AI, we need more AI, and I think that's an interesting paradox. AI is going to help us kind of understand nuclear fusion, which I think is going to have to be part of the future equation. It's going to help us be able to productionize the sort of small and modular nuclear reactors, which I think has to be part of the equation. I don't think we can totally rely on solar, for example, or wind. And so, I was in a really interesting talk earlier in the week where, if we want to optimize AI and become more sustainable to use AI, we need more AI.
Yeah, absolutely. I want to talk about, I'm glad you brought up fusion, right, developing technology areas that could totally become game changers, right, for the energy needed to power this infrastructure. Dave, I'm curious what you think about that. How optimistic are you that we could have, nuclear fusion start to really take off and become, a key pillar of energizing data centers like this?
Well, I think sustainability is really important to how we've thought about our data center build out to date. We have been bringing on 100% of the power that we consume from the data centers in terms of renewables back to the grid. So since 2020 in our data centers, we've been net zero, and that is an important part of what we try and accomplish. And so we've, I think, put something like 12 gigawatts of renewables, in contract, to date. And so that's like a big important commitment. But it's not, renewables are, traditional renewables like solar and wind are part of the equation, but we do think nuclear is going to be increasingly important. But it's got a long lead time, and fusion has got an even longer lead time. In December, we put out an RFP for 1 to 4 gigawatts of nuclear power. That's going to be something that we think would come online in the 2030s. So it's not a near term kind of reality. I think there's opportunities around sort of existing power plants to be able to use those for data center needs. But I think longer term, there's going to be a big play for nuclear here, whether that's small reactors, fission reactors. In the long term, fusion would be great. I think that's longer term than that.
Yeah.
If I can maybe add one thing that's kind of interesting that no one's maybe talking about, probably some people are talking about it, but the announcement basically says, hey, they're going to spend $500 billion, which would be very cool if they did that. But it's unclear to me exactly what the size of the largest data center is going to be in this case, right? Like what fraction of it is going to go to inference? What fraction is going to go to experimentation, right? If you even look at a company like Meta, a single training run is not using every H100 or whatever GPU type that they have, right? It's probably using a subset, and that is contiguous within a data center. So in theory, like not all of this power needs to go to a single data center. And also with things like RL, people are potentially finding out ways in which maybe multiple data centers that are not connected can basically contribute to a single training run, right? Which basically means you just need to find a way to get the capacity, right? You don't need a single generator of power that could do that, which would unlock even more value, right? So the details are not super clear, but maybe it's actually even possible today.
Chase, what do you think about alternative forms of energy, renewables, or maybe some of these new techniques that Varun was mentioning?
Yeah, I mean, like from our perspective, renewables are going to increasingly become, a bigger portion of, the future mix of energy consumed, both by data centers as well as just kind of broader electrification of things. Today, clean energy is actually cheaper than, legacy sources of energy production. We do need to sort of ramp up the supply chains to sort of continue driving that cost curve down. For intermittent renewables like wind and solar, there's certainly a number of innovations that need to happen on the storage side in terms of being able to provide 24/7 renewable energy. I think actually AI is an incredible tool to help catalyze that as well. I know a number of folks are actually working on leveraging AI and foundational models and things like DFT, diffusion function theory, to actually discover and identify net new battery chemistries to help drive down both the cost as well as the ability to sort of scale grid scale storage, which I think is a really fascinating, exciting application of AI. But our perspective is that the energy mix to power both data centers and increasing electricity demands is really going to be an all of the above strategy. There's no silver bullet. It's not just going to be more wind turbines or more solar panels. It's going to be wind, solar, new innovative geothermal approaches, new nuclear approaches, both large scale reactors as well as SMRs, fusion. Honestly, I think we should be building more hydroelectric dams. It's going to be really an all of the above strategy. And then one other area that we are spending time is gas generation with carbon capture and sequestration that really enables us to leverage existing fossil-based supply chains, but be able to produce power without the carbon footprint from generating those kilowatt hours.
I'm curious, what do you all think is the biggest challenge right now to executing on some of these ideas? When I talk to people in the industry, some of them say it's regulation. We need to fast track the ability to build and try out these new methods or revive nuclear power plants. Others, will say it's funding, right? And we've seen OpenAI, as I've reported, for several months been building up, trying to pitch this idea and get the support to get global investment to build data centers in the U.S. So what do you all think? Or maybe there's some other challenge that I'm not thinking of. What do you think is the biggest sort of potential blocker here, and how do you think we get past that?
I would. I think speed is of the essence right now. There's like an arms race unfolding. I'd be curious to get the meta perspective.
I think it's. It is kind of all of the above. There is funding is probably not the biggest concern right now. It might be in the future, but
you have a bigger balance sheet than some other companies.
A lot of this is being funded from hyperscalers who today have very strong cash flows, very strong balance sheets. So
trying to spend it all quickly.
There's an ability to invest here, which is helping support this large expansion. And I think there's a lot of opportunity that is being created in terms of what this can mean for the global economy and the value that will flow back from that investment. So I think the investment case is there. It's clear. I think all of the hyperscalers believe in the investment opportunity here. So I think there's a lot of strength behind the financial side to make a big investment here. But there's a lot of execution challenges. There's power, there's regulation as it relates to power. There's the supply chain itself. You've got, if there's any supply chain disruptions, that could completely slow down the process. There's in any given field, there's maybe only a handful of manufacturers doing things like gas turbines or transformers, and so there's a lot of places where there's potential for bottlenecks, and I think you see the industry responding and increasing capacity. But it's not just the hyperscalers that need to invest; it's the entire supply chain that needs to invest, and there I think you've got a more cautious attitude towards things, which I think we'll need to see get more aggressive to be able to support the execution that needs to happen here. So I think there's a lot of different bottlenecks, but hopefully we'll be able to execute through them. I think there's a lot of will and focus on novel solutions to get through this. So I think it will be an execution challenge, but one that the industry will rise to.
Costi, I want to go back to the global focus that you wisely brought up for a moment. What do you think is the biggest blocker in getting countries outside the U.S., especially in those areas where you said there aren't really enough data centers or energy sources?
So look, it is all of the above, but I'd say the priority varies by region. I mean, I would say in Europe, regulation is a big issue. You can spend 2 years getting planning permission to build a house, let alone sort of a data center. So, and I think in Switzerland is a bit like the UK in that respect. So, if Europe is going to keep up, we're going to have to look at some of these things specifically. I think in other areas of the world where, again, funding's not an issue, I would say overall know-how and understanding of the overall challenge is. So, we talk to companies that are very proud to be kind of in the front of the chip supply and saying we've got X thousand chips arriving, but they haven't really considered that you can't just put X thousand chips in racks. You have to somehow make them all communicate in a way that's very efficient. You need to get power to them. You need to have backup generators. And even though the chips are in order, the backup generators have a lead time of X years. So there is a little bit of being a little bit behind on know-how that I think kind of other regions of the world need to catch up with. But I would pick those two sort of areas as the most acute.
Got it. Varun, I saw you had something to say on this.
I guess maybe a question for you is Chase brought up 20 gigawatts, that would roughly account for this $500 billion, and you're talking about how 4 or 5 gigawatts is going to take, maybe it's going to come online maybe in 2030 is what I heard. Maybe I misheard what you said. How are they going to put together that much capacity in a short period of time, or is this going to take a long time?
I think it's going to take a long time to be able to put together the kind of capacity, and it's not going to be in one location.
Yeah.
We're like, for us, we're both looking at a bunch of small regions as well as making big investments in sort of large training centers. For instance, we announced that we're building a 2 gigawatt facility in Louisiana. So that's sort of going to be the place that we're going to train the next generation of open source llama models. So that's a very big, sizable project that we're building in one location. But there's going to be a lot of distributed opportunities here. I think distributed training, obviously inference is going to be done distributed. So I think there's going to be a lot of different places that the build out is happening. You're certainly not going to see $500 billion of capital go into one location. So it's going to be, I think, across the U.S., across the globe, in terms of where you're going to see the impact of all of the spend that's happening.
The first region, of course, in this announcement was Texas. That's where they're going to build the first data center already building, right? Chase, that's also where Crusoe, you mentioned, has experience with data centers. Can you talk a little bit about, these are actual physical structures that you have to build, right? And what is it, what are the challenges there? What does it look like? How does Crusoe develop what's needed? We were mentioning electricians earlier. I think that's fascinating how we might have a real shortage of electricians to power that. So just one example, but can you talk about how you build up in a region and what Crusoe's experience has been like there?
Yeah, so I mentioned earlier, we're building this big facility in Abilene, Texas, which coincidentally was a town that was mentioned in the White House announcement. I don't know, maybe something there. But anyway, I think it's it is, I think we've talked about this point quite a bit, but there are, the supply chain is complex. It's not just, I think the interesting aspect of AI is it's an inherently digital experience, right? You're interacting with it on your phone or your computer, or an whatever autonomous robot or something like that. But it's an inherently digital experience that, in order to make it happen, requires this massive physical infrastructure investment. So the supply chain is complex between steel, construction workers and crews and equipment, to lay foundations, pour cement, install, backup generations, switch gear is like a big bottleneck. Transformers, there was a period where high voltage transformers, lead time was 5 years, and this is just wound copper. It's just a crazy thing. And to Dave's point, we've tried to take a lot of the supply chain in-house. within Crusoe to try to mitigate as much of those supply chain risks as possible. So we actually manufacture a lot of the key critical electrical components that go into building the data center, things like switchgear and PDCs, power distribution centers, that you really need to build this type of infrastructure at scale. One comment I want to make though is that just thinking about like why we're doing all this, like because these are the biggest construction projects, the largest capital investment in anything in human history. Like why is it all happening? Where's the demand really going to come from? I think there's an element of reflexivity to all this giant AI boom, which is that as AI models get better, as folks are really pushing the bounds in terms of improving the quality of these models, they become more useful. And when they become more useful, people use them more, right? So the consumption is reflexive in that sense, which I think is, everybody, the forecasts are very murky, right, in terms of what true adoption looks like. But I think as things get better, they will be used more, and they will require these massive amounts of infrastructure and breakthroughs like test time compute scaling, which is what is like the core piece of O1 and O3, this sort of chain of thought mechanism in terms of taking results and really the model really thinking about these results and thinking, do these actually make sense to produce more intelligent results, really just scales the overall demand in an even more incredible way.
Yes.
Yeah, I think it's an interesting point here because a lot of the compute analysis that's done is really based on the fact that a lot of these models are using the transformer algorithm, which is now 8 years old and is amazing, but is very computationally intensive. And we're seeing some very, very different approaches arising with new algorithms that are massively more efficient. Now, I'm not here to predict whether these will actually become mainstream or not, but we could actually see another revolution similar to the transformer revolution from 2017 that might make a big difference in terms of efficiency and might actually allow us to use existing capacity a lot more effectively.
Yeah, that's a good point. Dave or Varun, anything to say just on the physical locations where these will be built and the kind of physical challenges there and how you overcome those?
I think just what's been said, I think there are a lot of bottlenecks. You need to factor into those bottlenecks into how you're thinking about constructing the facility that you're building. You need to think, you need to be creative in how you're going to approach things because you're going to have more constraints than you would have 5 years ago. So you're going to need to rethink how you do a lot of things, whether it's the actual physical building design to be more modular, whether it's the networking. You need to rethink a lot of the fundamentals that you had going into it, factoring in the new constraints to the model. And I think that's what you're seeing a lot of the hyperscalers react to, and obviously companies like Crusoe that are innovating there. So, I think it's about responding to the environment that you're in, and the environment that we're in is going to have a lot of constraints. And then you're going to obviously need to work with the local communities where you're building these data centers to make sure that you are bringing online adequate power to the grid so that they don't see increases in rates and other things like that could negatively impact them. So you need to think about it not only in terms of your physical constraints, but also public policy and other issues to make sure that the overall package that you're bringing into the community is workable. So I think there's a lot of different things that need to happen, and I think we're trying to work on all of those things creatively and trying to solve problems and also deliver on our sustainability goals. So it's a big set of things to optimize for, but I think we're trying to rise to the challenge.
Okay, I want to end with anyone who has predictions for the year ahead. Either it can be anything about AI, infrastructure, or AI generally, but
I think 2025 is going to be the year where inference actually is consuming more compute capacity than training. I think this, what I was mentioning earlier, scaling of test time compute really brings, training level compute, requirements to inference queries, and I think you're going to see that trend continue to accelerate.
Costi?
I try and avoid making making prognoses in this field. But I think just to take a slightly different view, we've talked a lot about sort of the technical infrastructure in this talk. And when it comes to driving value in businesses and all society, I would say there's a business infrastructure and a human infrastructure that sits on top of that. And I'd like to think, perhaps optimistically, that next year is going to be the year when businesses actually start changing the business infrastructures and the human infrastructures to take advantage of AI a lot more and actually to drive some of the efficiencies that we've been talking about today.
Varun?
Yeah, I think this is just a general point, but I think open source is going to catch up like very, very quickly.
I think Dave would agree with that.
Yeah.
Hey, I love it.
Yeah, I think just the outcome of what DeepSeek and obviously Meta is going to do is like there was probably a persistent feeling that hey, this stuff is going to be a year or two behind, but it's very clear the gap is getting really small, right? Like O1 comes out, DeepSeek R1 may not be as good as O1, but this is like a very, very short time horizon, right? And I think this goes to show that ideas aren't like a monopoly. No company has a monopoly over an idea. This is like any classic, like technology. And especially AI is not a technology that kind of compounds on itself, right? Every sort of generation, when a foundation model comes out, it wipes out everything you did in the past, which is that no one cares about the foundation model you previously released once the new one comes out, which means that the set of players that are relevant is changing basically every 3 to 6 months. So exciting to see what's going to happen with open source and the gap between that closing.
I'm excited about what's going to happen with open source as well. I think we're going to be, we launched our first generation of Llama models in 2023. We launched Llama 3 in 2024. Our family of models there had a lot of impact. I think created a lot. We have like, I think 700 and, I think we get like 1 million downloads a day. So it's like 770 million downloads of Llama since we launched it originally. There's like 85,000 derivative models. We're launching our new family of Llama models, Llama 4 in 2025. So I'm super excited about that. I think there's going to be a lot of new capabilities, whether it be speech and reasoning, video generation. So I think there's going to be a lot of innovation brought to the market and specifically in open source. So very excited about that. And I think that's going to have a lot of impact in 25.
Great. Well, thank you all. That was a fascinating conversation, and thanks for sharing all your predictions with me. All right, thanks.
Thank you. Thanks.